So, good morning, everyone. Today, we are going to start a new chapter in our AS Level Mathematics playlist, and that is about integration. Okay, so we will see what is the first topic that is there in your chapter. Okay, so it is 9.1. We are going to start the first topic, and that is now we will see integration as reverse of differentiation. Okay, so earlier you have studied this topic, that is earlier you have already studied differentiation. Now we will see that there is one more mathematical machinery that is just reverse of differentiation. Okay, it is reverse or opposite of this topic, that is differentiation, and it is known as integration. Okay, so in a simple terminology, a differentiation means what? Differentiation means, the meaning of differentiation is to break down. Okay, to break down in smaller parts, to break down in smaller parts. Okay, and the meaning of integration is just opposite of this. The meaning of integration is to sum, to take the summation. Okay, to sum all smaller parts. Okay, so in differentiation, for example, if this is a piece uh, piece of circle, just assume it is a circle. If I am breaking it in smaller part, for example, this is one small part. Okay, so if this is one small part, similarly this is another smaller part. Okay, like this. Okay, so if I am chopping it in smaller parts, you can assume that we are doing the procedure of differentiation. But similarly, if I actually sum all these smaller parts, okay, if I arrange all these smaller parts like this, okay, so it will become this entire shape, and this process will be known as integration. Okay, so this was just a simple layman English explanation for these two words, that what do we mean by integration and differentiation. So we will see that what does these words mean in mathematics. Okay, so this you have already studied, that the derivative of x raised to the power n is what? For example, your function is y is equal to x raised to the power n. Then if you want to take the derivative of this, it will be y dash. It will be n x raised to the power n minus 1. Okay, this is the value of the derivative, and another symbol of y dash is nothing but dy by dx. Okay, so these both are equivalent symbols. Okay, so the value of dy by dx is nothing but nx raised to the power n minus 1. So this was for differentiation. Okay, this formula was for differentiation. Okay, but for integration we have something else, and it is this formula. Okay, that if you have y is equal to x raised to the power n, then the integration, okay, integration, okay, if we want to find the integration of this, so what I will do here, I will actually apply the integral sign, and the integral sign is like this. Okay, so I will apply the integral sign on both of the side. So integral, okay, so I am showing you a rough steps to perform the integral here. Okay, so first I have put what? I have put you just be with me step by step, and I will show you how the formula of integration is derived for all the cases. Okay, then we will see how this formula that is given in this key point is also derived. Okay, so I am applying the integral formula on both the sides. Now see, the variable present here on the right hand side is x. Okay, so I will write dx here. Okay, similarly the variable that is present in the left side is y, so I will put dy here simply. And now let me show you a very crucial formula, that is the, you can say, the most basic formula in our entire integral study, and that is this formula that is present in your textbook as key point 9.4. Okay, so the formula is if you want to integrate x raised to power n dx, formula is you will increase the power of this n by 1, You will divide by this n plus 1, and then you will add a number c. This is known as constant of integration. Constant of integration. This is constant of integration. And this c is what? It belongs to any real number. C can be any real number. Okay. And see, the denominator, since the denominator, the division by 0 is not possible, so the value of n can be any integer. Here n can be any integer. This formula is applicable when n is any integer. The only thing is n should not be equal to minus 1. This formula is applicable for all the integer. N can be any integer except minus 1. Okay. So this is the general formula for integration. Okay. This is a formula. uh, you do not need to think more about how it is derived. Okay, but for derivation you can also consult some of the higher textbook, but right now it is not required. So first we will actually build our calculation tools. Okay, how we actually calculate things in integration, and after that we will see how this formula and all this concept of integration is derived when we see the geometrical aspect of this concept. Okay, so now, since we know the formula, we will apply the formula here. The formula will be what? Now see, in the left side hand side, the variable is y. So it will be y dy, since the power of y is nothing but 1. So I am simply 1 plus, it will be 1 plus 1 divided by 1 plus 1. Okay. Plus c. Okay. Let's see if I apply this plus c1 in order to, because see, here also one a constant of integration will be there. Here also there will be a constant of integration. So I am just, okay, I am putting this constant of integration on the left hand side. Similarly, if I apply the same formula, it will be like this. So it will be some another c2. Now see what will happen here. It will be converted into y square upon 2 equal to x raised to the power n plus 1 upon n plus 1. I can also take this constant of integration, this c1 on the right hand side, and this entire c2 minus c1 I can depict as simply another c. I am replacing this c2 minus c1 by some other constant of integration. Okay. So in this step, in this particular example here, if I am integrating this y equal to x raised to the y equal to x raised to the power n, if I am taking integration sign on both hand side, so this will be our result. It will be y square upon 2 is equal to x raised to the power n plus 1 upon n plus 1 plus this constant of integral c. But our problem is that they have given us this dy by dx, this dy by dx, okay, equal to x raised to the power n. Okay, so now we will see that what happens when we have not y. So now see, earlier we had this y, but now in place of y we will, if I have some derivative term like this dy by dx, we will see what we do if we have the derivative term. Okay, so first let me erase all the things that I have written here. Okay, and then we will see. So now since you know the formula of integration for x raised to the power n. Okay, so we do not have to worry much. Okay, so okay, so what I will do here, I will apply the similar procedure. First I will write dy by dx equal to x raised to the power n, and now if I apply the constant of integration on both sorry, the operation of integration on both sides, it will become dy by dx. Okay, but since I already explained you that on left hand side I will apply this dx. Okay, similarly on the right hand side it will be dx. And now maybe you will be asking that why you are using the variable. Earlier we asked about the user, that earlier we have multiplied by dy, but now we are, why we are multiplying by dx. Okay, so we are multiplying by dx because you know the y was nothing but a function of x. Okay, so when you are taking the derivative dy by dx, this will be f dash x, and this f dex will not be a function of y, but it will be a function of x. Okay, so this dy by dx here, dy by dx, you can also think that it is a function like this, and it is a function of x. Okay, so we will apply this dx or dy depending on the function that dy by dx is function of either x or y, depending on that. Earlier it was simply y. Okay, so y is nothing but a function of y itself. That's why I have multiplied by dy. But now in this case, I will multiply it by dx. Okay, so now we will proceed further with the same methodology that we have studied. Okay, okay. So, and this is for your rough. It is just for your rough calculation. Okay, I'm not saying that this is a standard calculation that you show in your answer sheet. It is just for a rough calculation. It's so that we will be arriving at this formula. Okay, just a rough derivation. Okay, this is not a standard derivation. Okay, so I'm just cancelling this dx with this dx, so I have only this part left, that integral of dy is nothing but x raised to the power n dx. And now since you know the formula, in this formula what is present with dy, there is y is also present in left hand side, but in a very hidden form. It is nothing but y raised to the power 0. Okay, because 1 is present in front of dy, so I can write that it is y raised to the power 0, because that formula was applicable for all the value of integer, so it is also applicable for 0 as well. So if I apply that formula here, it will be 0 plus 1 divided by 0 plus 1 is equal to, and I already explained you that I can take the constant of integration from left hand side to right hand side. So it will become x raised to the power n plus 1 upon n plus 1 plus c. Okay, so this will imply that y is equal to x raised to the power n plus 1 upon n plus 1 plus c. Okay, okay. So I hope that you understood how this formula is derived if you have a derivative term at the left hand side. Okay, and this formula is nothing but the application of this very basic formula that we have learned in the very first step in our integration chapter. That is, the integral of x raised to the power n dx is nothing but x raised to the power n plus 1 upon n plus 1 plus c. Okay, and this formula is applicable for all the value of all where n can be any integer. Okay, n belongs to integer, except n cannot be minus 1, because otherwise we will be having a division by 0 case, which is not allowed in mathematics. Okay, so now we have some other points, some other rules that is uh, in the integration formula. So the very first rule is that if your function is multiplied with some constant k, here we have a constant k that you can see, this constant k. So the rule says that you can take this k outside of your integration sign. This is the integration part, and the k has come outside. For example, if you have a function like 2x square dx, if you want to integrate it, so according to this formula, what you can do is you can take this 2 outside. You have this 2. Okay, this is the constant, so you can take this 2 outside and you can write it simply x square dx. Okay, so this was this rule. Okay, and all these, actually, see, all these rules, it is not that they have just come from the sky. The thing is that rule this rule is derived from some of the geometrical aspect of integration. Okay, and that we will see, if the time permits, we will see all those derivation also. Okay, similarly, the next rule is that if you have two functions in addition or in subtraction like this, f of x plus minus g of x with the integration sign, you can distribute this function across the two integrals. Okay, so for example, if I apply this here in order to find the integration of this function. Okay, so now I can consider the first function to be f, second function to be g. So what I can do, I can simply write it as 2x then I will write plus sign, then 3x square dx. Okay, so this plus sign is appearing here. And now see, because we have learned one another rule, that this constant of integration can be taken outside. So I am taking this constant of integration outside. It will be 2x dx plus 3x square dx. Okay, so right now you do not worry about how this integration will be solved. It is only that you need to know how these two rules are applied. Okay, how you distribute two functions over the addition sign, and how you take the constant of integral outside your integration side. Okay, so with the help of these two rules, we will be going to solve these two example that is given in your textbook. Okay, so in order to solve this first question, first we need to know the value of this expression, right? Okay, so we will just apply our basic algebra, and we will multiply it term by time. So first I am multiplying this x with this first expression. It is 2x square minus x, then it is 2x plus 3. Okay, so it will be nothing but 4x cube plus 6x square minus 2x square minus 3x. Okay, so it means that this entire expression is nothing but this value. Okay, so if I integrate this 4x cube plus 6x square minus 2x square minus 3x, and I am um, keeping it in the bracket, so that it will we should avoid all the mistakes here. So what the rule says that we can actually distribute. So now see, now we have sum of how many function? 1, 2, 3, 4. We can take it as four different terms. Okay. So the rule says that even if you have two or more than two terms like that, okay, if they are separated by this addition or subtraction, you can distribute it over the integral sign. Okay. So it will be like this: 4x cube plus 6x square, then minus 2x square, then minus 3x dx. Okay, and now you know that now we have only this constant terms can be taken outside, so it will become, this is equal to, it will be 4, it is x cube dx plus 6x square dx minus, this is 2x square dx, this is minus 3x dx. Okay, so what I have done, I have taken all these constants 4, 6, 2 and 3 outside. Okay, outside our integral sign. Okay, so now I will apply this formula. Till this point I have only one formula, and the formula is that the integral of x raised to the power n dx is nothing but this value right over here. Okay, so I will apply the same formula with different values of n. Okay, so this will become 4. Now it is x cube, so it will be x cube plus 1 divided by 3 plus 1 plus 6. It will be x square plus 1 divided by 2 plus 1. Then it will be 2 into x 2 plus 1 divided by 2 plus 1. Similarly, 3, oh sorry, why I have put this integral sign. Let me erase this thing first. Okay, so it will be x raised to the power 1 plus 1 divided by 1 plus 1 and one constant of integration. It is not that if you have four or sorry, for example, two or more terms, then you will put two or three constant of integrations, because ultimately they all can be added up and they will be reduced to only one constant of integration, that will be just a simple c. Okay, so now if I simplify these terms, it will become, this is equal to 4, it is x raised to the power 4 upon 4 plus 6 x raised to the power 3 upon 3 minus 2 x raised to the power 3 upon 3 minus 3 x raised to the power 2 upon 2 plus c. Okay, so now we can cancel this 4. I can also write it as, I can cancel it 2 times. Now nothing will be cancelled. Okay, so our answer is nothing but x raised to the power 4 plus 2x cube minus 2 by 3 x cube minus 3 by 2 x square plus c. Okay, so this is our final answer. Okay, and now I am assigning one question for you for your practice. Okay, this is your question. You can please note it down and please try this question as your homework. Okay, because the main thing, you learn mathematics not by watching videos. Okay, watching is very simple thing in mathematics. Okay, you learn it only by doing mathematics. Okay, so your first target should be you watch the videos. Okay, and your second thing that is more important than videos is by doing mathematics. Okay, so you apply the formula. You first, so the first step I'm just doing giving you the outlines of solving this problem is, first distribute this x over all these two terms. Okay, first take the denominator, separate this denominator in these two terms, separate over them, and after that you proceed with this problem, and you apply the only formula we have learned is this integration is what, x raised to the power n plus 1 upon n plus 1 plus c. Just apply this formula with different value of n and you will get your result. So I hope that you understood all this concept pretty well, and just try to see what is the uh, what is the value of this integral. Okay, so for your convenience, let me give you the value of this, the answer. Okay, so that you can actually cross check yourself whether you have done it correctly or not. Okay, so the answer for this exercise is, it is 2x square minus 6 root x plus c. Okay, the answer is 2x square minus 6 root x plus c. Okay, so this is the answer. Now this is given you the answer for this question. Now you just tackle this question and arrive at this answer. Okay, so best of luck for this homework, and I hope to see you soon in my next video. Thank you very much, everyone.